at this linear system, we can see that our variables are lined up. But there's not an easy way, if we wanted to solve this with combination, that we could just add them together. So in this case, we're actually going to have to multiply one of the equations by some number to get one of our variables to cancel out. Here's what I mean. If I look here at my x's, there is something we can multiply 2 by, so it would equal a -5, but it's not going to be quite so easy. But if you look here at the 4 and the 8, I know if I were to go 4 times 2, that would give me an 8. And because this is a minus, I don't have to worry about multiplying by a negative. Now if this was a plus, then I would multiply it by a -2. Because remember, we want to get opposites. Let me show you what I mean. Let's take this first equation here and let's multiply it by 2. Watch what happens. Now remember, we can multiply whatever we want as long as we do it to both sides. So if I multiply this side by 2, I get 2 times 5x, which is 10x. And I'm going to go keep, change here just for ease. And I'm going to go 2 times a -4, and that gives me plus a -8y. And then I also have to go 2 times 3, which equals 6. Here's why I want to do that. If we just move this bottom equation over, I'm not multiplying anything here. I could have if I needed to, but I'm not at this time. The reason I did that is because now my y's are going to cancel out when I combine them. Okay, we're going to use linear combinations to solve. Piece of caution here. This is where people make their mistake. They're good about going 2 times 5x to get 10x, and people are good at going 2 times a -4 to get -8. But they forget that you have to multiply both sides of the equal sign. So if you're choosing to multiply by 2, you can. Just make sure you multiply everything by 2, or a -2, or whatever it is you multiply. Now if you look here, if we have 10x's plus 2x's, that's 12x's. Here's the kicker. This is why we wanted to multiply by 2. -8y's plus +8y's cancel out. And 6 plus a -2 ends up being 4. You divide both sides by 12. X is going to equal 4 goes into itself 1 time, 4 goes into 12 3 times. Now notice I didn't write this one as a decimal, and the reason for it is because this gives me 0.3 repeating. I don't want to do that. I don't want to write 0.3 repeating because I need to be able to substitute this value in. So that's why I'm going to leave this as 1/3. So we're going to take this now, this 1/3, and we're going to plug it in for x. And you can plug it into either one of them. It doesn't matter. I'm just going to plug it in, I guess, to the second one here just for ease. And so I'm going to go 2 times 1/3 plus 8y equals a -2. 2 times 1/3, remember you can write as 2 over 1 if you want. That becomes 2/3 plus 8y equals -2. Now I'm going to subtract 2/3 off each side. And I know you guys, this can be a pain because we don't want to have to deal with fractions, but you can do it. This cancels out. I'm left with 8y's equals, now here remember we have to have a common denominator. Our common denominator is 3. So I'm just going to multiply the top and bottom of this by 3. And what I get is a -6 over 3. That's equivalent to -2. And so -6/3 plus a -2/3 is a -8/3. Okay, again, guys, it takes a little bit more thinking, but it doesn't, not like it's taking a ton more room. Then what I'm going to do is I'm going to divide both sides by 8, but I realize over here I have a fraction. So remember, dividing by 8 is the same thing as multiplying by the reciprocal. And I'm just going to write it like this because I knew I had a fraction over here. Y now equals, if we cross reduce, -8 goes into itself a -1 times, and 8 goes into itself 1 time. So this becomes a -1/3. So our x value is 1/3, and our y value is a -1/3. And you should, I'm not going to take the time to do it in this case, but you should plug it in here. Maybe I'll just do one of the examples. our x value and our y value. So if I go 5 times 1/3 plus, don't forget this is negative, a negative 1/3. We want to know, does that equal 3? If I can get my pen to work here. So 5 times 1/3 is 5/3 plus 2 negatives here is going to become positive 1/3. Does that equal 3? Well, 5/3 plus 1/3 is 6/3. And that does not equal 3 because I forgot my 4. See, good check though. Either I had to do something wrong. Try this again, sorry about that. Okay, plus a negative 4 times a negative 1/3. 2 negatives still would be positive, and this becomes 4/3. 5 plus 4 is 9. And we want to know, does 9 divided by 3 equals 3? Yes, it does. And you could plug it into the second equation here, and you would see that it also works. Okay, so please don't be intimidated when you're dealing with fractions. Okay, let's look at one more example. Notice in this system, our variables and our constants aren't lined up. That's not really a big deal. You just need to make sure that you do line them up that way. So in this case, and you can line it up however you want. I'm gonna because I am gonna subtract 3y from each side of the second equation. Now, do you have to do that way? No. You could have added 6y and made it look like this one. Okay, doesn't matter what you do as long as you line them up. So when I do that, I get a negative x, this is gone, equals 6 minus 3y. Still doesn't look exactly like this, so I'm just going to switch it over. Okay, so again, when we're solving a linear system using combinations, you have to first make sure everything's lined up. So I'm going to have 3x equals negative 6y plus 12. And then my new equation, which I kind of worked around here, negative x equals, and I'm going to flip these two around so my y's are together, a negative 3y plus 6. Now, that's step 1. Step 2, you have to multiply the equations by something to get a variable to cancel out. It's up to you what you want to multiply by. Well, I shouldn't say that. It's up to you what variable you want to get rid of. I could multiply this by 2 to make my y's cancel out. I could multiply this by 3 to make my x's cancel out. I'm gonna, I guess, multiply and get rid of this y here. Now the reason I want to do that is because I don't want to end up with a 0 on this side. Could I? Yep, but just for the ease of things, I am going to multiply each side here by a negative 2. Why negative? Because I want this to become a positive 6. Okay, and again, you guys, there are different ways you can solve these. Once you line up your variables, like I did it, or a different way, then you multiply by something so you get one of your variables to cancel out when you combine them. All right, so after doing all this, we have 3x equals negative 6y plus 12. Negative 2 times a negative 1x is going to be a positive 2x. Negative 2 times a negative 3y is going to be a positive 6y. Plus negative 2 times 6 is a negative 12. Now, when we combine them then, because our whole goal here was to get opposites, 3x's plus 2x's is 5x's. Notice these cancel out, and, well, these cancel out too. So what are we left with over here if everything cancels out? 0. And if we divide both sides by 5, we're still going to have 0. Okay, that's okay. Remember, our x value can be 0. That's all right. That means if you were to graph it, it's going to lie right on the x-axis. I'm sorry, right on the y-axis. Now, plug it back in. Doesn't matter which one you plug it into. Absolutely not. I'm just going to pick the second one because that's where my x is almost by itself. And I'm going to take the 0 here and I'm going to plug it in for x. So I'm going to say a negative 0, which hopefully we know what that means, plus 3y equals 6. that cancels out. So I have 3y equals 6. Divide both sides by 3, and we get y equals 2. So we have our solution, 0, 2. Okay, and again, you should check that real quick. I'll just do one example here. 3 times our x value of 0. We want to know, does that equal -6 times our y value of 2? Sorry, this is -6 times 2 plus 12. Well, 3 times 0 is 0, and -6 times 2 is a -12. -12 plus 12 is going to be 0, so it does work. And you can check the second equation too and see that it works. Okay. Again, when we have a problem like this, remember, you just have to line up your variables. You could line them like I did, or you could have added 6y to each side and put all your x's and y's on the left side. Once you have them lined up, then multiply one of the equations by some number so you end up with opposites like I did here. Again, you could have chose to multiply the first equation by something. You actually could multiply both equations by something, as long as you get a variable to cancel out. Once you do that, you solve for that one variable, plug it in back into one of the equations, and solve for your other variable.